This is your 11.1 sequences in summation notation. The sequence is a set of numbers written in a specific order, such as A1, A2, A3, all the way till AN. Let's go ahead and first find the first five terms and the hundredth terms of AN. Well, the first term is, in case I plug in 1 for N, I will have 1 over 1 plus 1, which is 2. The second term, I plug in 2 for N, I will have 1 over, this time it will be 1 plus 2, which will be 3, and so on. 4, 5, 6, and it will go all the way till the hundredth term is, in case I plug in 100 here, I get 1 over 101. Let's do the same thing for B. For B, I'll start by plugging again 1 for N, and I will end up with negative 1 over 2. I plug in 2 for N, that will turn negative 1 into an even number to give me 1 over 4. After 1 over 4, I plug in 3, it stays negative 1 over 8. It will keep alternating the sign, negative, positive, negative. The next one will be positive 116, then negative 132. And if you keep going up to 100, that will be 1. If you plug in 100, it will give you a positive 1 over 2 to the power of 100. All right, find the n terms of each sequence. This time is somewhat the reverse of what I did here. This one I had a formula and I'm expanding it. I'm writing the terms. This, on the other hand, I have the first 1, 2, 3, 4 terms, and I'm trying to write a formula. Now, in order for you to write this formula, note that this is kind of 2 over 1. So this is first, second, third, and fourth term. If you look at the top, for the first term, the top seems to be 1 digit extra. For the second, 1 digit extra. So I would say S of n is equal to n, which is the number of terms, plus 1 over n. So S of 1 would be 1 plus 1 over 1, meaning 2 over 1. 2 plus 1 over 2, meaning 3 over 2, and so on. Let's go ahead and look at the second one. This is S of n again, that I'm trying to find. This being the first term, the second term is positive. When I see negative, positive alternating, I know that it will be a negative value that is being raised to a power of n. Now, what value would that be? In order for me to get negative 2, the value must be 2. So I believe it's negative 2 to the power of n. Now, let's check. First, second, third, fourth, and fifth term. 2 to the power of 5 is 32. With the negative, that would be negative 32. Another way of writing this would be S of n is equal to negative 1 to the power of n times 2 to the power of n. But of course, the first one seems to be the best. For number 3, let's find the first 5 terms of the sequence defined recursively by this expression. So the first term is A1. So A1 is 1. I cannot change it. The second term is, now I plug in A1 here. That will be, second term will be A2. In order for me to find A2, I would say is equal to 3 times A2 minus 1 plus 2. But A2 minus 1 is A1. So I would say 3 times A1 plus 2 would be my A2. But A1 is 1, that would be 1 plus 2, 3 times 3, that would be 9. If you repeat this process for every single one of them, this one tells you actually the following term is equal to 3 times the previous term plus 2. So for this one, it will be 3 times. The previous term is 9. 9 plus 2 is 11 times 3 is 33. Same thing. I plug in now 33. 33 plus 2 is 35 times 3 would be 105. One more. I plug in 105. 105 plus 2 is 107 times 3 is 321. I'll do the same for B. F1 is the first term, F2 is the second, Fn is equal to the sum of the previous two terms. So to find f3, f3 is equal to f of 3 minus 1 plus f of 3 minus 2, which is equal to f of 2 plus f of 1. In other words, the third term is the sum of the first and second. The fourth term will be the sum of the second and third, and so on. So this one, f1 is 1, followed by 1. The next one will be 2, because it's 1 plus 1, 2. 2 plus 1, 3. 3 plus 2, 5. 5 plus 3, 8. 8 plus 5, 13. And 13 plus 8 is 21. This one is actually what we call the Fibonacci number. That's Fibonacci. Alright, let's go ahead and talk about series. The series is the sum of the sequence, A1, A2, A3, all the way, by adding them all up. A partial sum is the sum of the finite number of terms. So I can say the sum of the first 5 terms, that will be a partial sum, but a series is the sum of all terms. For example, S5 is called the fifth partial sum and is the sum of the first 5 terms of the given sequence. This symbol means summation. The summation goes from k all the way, k equals 1 all the way to n of s of k. So this is actually a1 plus a2 plus a3 plus a4 plus, you keep adding all the way till an, because I start at a1 and I end at an. Find each sum. This one starts at 1, ends at 5 of k to the k squared. So this is actually equal to, in case I plug in 1, I will have 1 squared plus 2 squared plus 3 squared plus 4 squared and plus 5 squared. And if you add them all up, you get 1 plus 4 plus 9 plus 16 plus 25, and the total should give you 55. I'll do the same thing this time with b. b is the sum of 1 over n, so it's starting at 3, so it's 1 over 3 plus 1 over 4 plus 1 over 5, which is equal to, find a common denominator, you should end up with 47 over 60. I'll do the last one now, meaning C. For C, I'm looking for the sum starting at 1 of 2. But guess what? If I plug in 1, I get 2. If I plug in 2, I get 2. 3, I get 2. 2 again, it will end up being 6 2s, or I should say, yes, 6 2s. 1, 2, 3, 4, 5, 6 2s, which is just 12. The last portion of our note says, write each using sigma notation. Well, this is a sum of, it starts at 1, I would say k goes from 1, it ends at 7, all the way to 7. Now, as it seems like every single time the value is being cubed, so I would say k cubed. This, on the other hand, is a sum. It starts at 3. That means k goes from 3 till 77, and I see it's all inside of square root, so I will say square root of k.